Hey everyone, welcome back to this DP-700 exam preparation course, and today we're going to move on and we're going to be talking about orchestration in Microsoft Fabric. Now there's a few different item types that we can use for orchestration in Fabric. The main one is going to be data pipelines. Hopefully you're familiar with data pipelines. So we're going to be going through data pipelines and how they can be used for orchestration. We're going to be looking at some orchestration patterns that you might commonly want to implement in a data pipeline or in a notebook. And then towards the end of the session, we're going to look at using Fabric notebooks for orchestration, right? So we can use a library, notebook utils library, to perform orchestration of other notebooks. So we're going to look at what that looks like. And we're going to finish the session today by looking at various triggers that are available to us in Microsoft Fabric. So let's dive in. Okay, so let's just start off with some of the basics of data pipelines. In a data pipeline, we have a number of different activities available to us. And this is one of the massive benefits of data pipelines. We can use it to orchestrate, meaning to trigger the execution of lots of other things in Microsoft Fabric. So this first block here, we have a number of different experiences or Fabric items in Microsoft Fabric, like the notebook, the data warehouse, the KQL experience, Spark jobs, and all of these things can be triggered by a data pipeline. We also have semantic model refreshing down here. So if you've got a semantic model and you want to trigger the refresh programmatically based on some trigger that we're going to look at in the last section of this video, you can also do that. So another really useful tool that we have in data pipelines is this invoke pipeline activity, which essentially allows you to run another pipeline from the pipeline that you're calling it from. And we'll look at how that can be useful for various different frameworks and architectures that we could build with our pipelines. But it's not just Fabric items that we can trigger from a data pipeline. We can also use a wide variety of stuff. Essentially allows us to orchestrate various other services that we might have in our organization. Okay, these are just a selection of those. So we can trigger Azure Database Notebook runs. We can trigger Azure functions. So if you have a lot of Azure functions in your business that do some sort of ETL process, you can trigger them from a Fabric data pipeline, and also a lot of other stuff in Azure as well. We also have things like webhooks. Okay, so if you have any sort of services that you want to trigger via a webhook, then that is also possible. The final kind of family that I'll just mention up front here is around notifying. Now we're going to do a whole section around error handling and monitoring, but I just want to call out that we have the Office 365 activity and the Teams activity. So this is another benefit really, because we can control over when you fire off notifications to people in your team or anyone in your business really. And so we get this control over when things go wrong or when things go right, we can notify the right people in your business. So one activity that I didn't mention there was the copy data activity. And I wanted to focus a little bit more time on the copy data activity because it's arguably one of the most important activities, right? Especially for data ingestion, because it's one of the primary mechanisms, at least in a data pipeline, for getting data from various external services into Fabric. And it's actually very multifunctional. We can use it in a variety of different ways. If you go into a data pipeline and you create a copy data activity, the first thing you'll be asked is to create a connection to a source. And there's lots of different sources that you can select. This is just a selection of them here. So you see that there's a wide variety of primarily Azure services, but there's also some interesting ones that I'd like to pinpoint. So the SQL Server database connection is really useful when you have on-premise data because you can connect via the on-premise data gateway. Now, the copy data activity is one of two main ways. You can also do this from a data flow Gen 2, connect to on-premise data via this on-premise data gateway. So that's really important to know there. The other one is this REST connection, right? So if you have REST APIs that you want to connect to and you want to perform some sort of GET request or POST request to that API to extract some data, it even allows basic pagination, okay? So if that API returns some pages, some paginated results, I put basic pagination because it can get a little bit messy if your API has somewhat unique pagination functionality, but it is available there for you to do pagination and things like that. Now, if your REST API requests get a little bit more complex, then I definitely recommend to move into the notebook world for your REST API data extraction, but it is available in a copy data activity. Finally, I'll just pinpoint the HTTP request. So that's if you want to extract things like website data or anything that's openly accessible on the internet. So there's many different methods and connections that we can create on the source side. But this is a copy data activity. So we're copying data from the source and then loading it into a destination. And again, there's various destinations that we can choose with a Fabric data pipeline copy data activity. If you're talking about file data, well, obviously we can load it into a Lakehouse files area. Tabular data can be written into essentially any Fabric data store that we have in there. Plus, and not many people are aware of this, but you can also write to external data stores as well, like an Azure SQL database. So you could trigger these ETL processes from within Fabric, but that doesn't necessarily mean that your destination has to be within Fabric for these. So let's just look at a very simple pipeline and then we'll build up the complexity and we'll talk about some of the key features. You might find that the copy data activity is a pipeline in itself, right? This is all you need to do. You just want to get some data from one location external to Fabric and load it somewhere in Fabric, okay? So you'll create a copy data activity and you set up a connection and you have this relative URL section here. And what you see here is I've currently hard-coded this value, which is not ideal, but we'll talk about how we can improve that in the future slides. You're also going to say, oh, this is a HTTP request, this connection. So it's going to return a file format and we're going to specify what that format is. So Fabric knows what to do with it. It knows how to pass the response. So that's what we're looking at here at a very, very basic level. Now, if we zoom in on this copy data activity a little bit more, most pipelines we create, well, they're not really going to be single activities, right? That kind of defeats the object. The real benefit from pipelines comes from the fact that we can build these directed acyclic graphs, right? A DAG, which essentially means we can connect various activities together with dependencies between them, right? So we're going to say, I want to start with this activity, and then if that's successful, I want to do this second activity. And so we can build up this logic in our pipelines. Now, to implement that, you need to be aware of these 4 condition flags here. So when you're connecting activities in a data pipeline, you'll need to select one of these 4 here and then connect it to the next activity in your pipeline. And obviously, whichever of these 4 conditions you select, it will impact how those activities are related, okay? So the first one is on skip. So if you declare an on skip condition, the next activity will run only if the previous activity is skipped, okay? So if that doesn't run, this copy data activity, for whatever reason, perhaps you have some sort of other logic where you have another activity down here and it actually goes through this activity but not this activity, or if you're in a for loop and this one doesn't run because it exits the for loop, for example, before it has time to execute this activity. Whatever that reason is, if this activity doesn't execute, only then will the next activity run, okay? The next one is on success. So this is probably the most common one. And this basically means that the next activity will run only if this previous activity is run successfully, okay? We've also got on fail. So this means that the next activity will run only if previous activity fails. So you might want to use this for things like notifications, right? Finally is on completion. This means that the next activity will run when the previous activity completes. It doesn't matter if it is successful or it fails, right? Either way, that next activity will run. So we can connect up our activities a little bit like this. So we might start by getting some data from an external location, then we might load it into a Fabric data store. Then we might want to do something like a semantic model refresh, okay? If you're using direct late mode, but you've turned off the auto reframing, then this might be a good use case, right? And then if the semantic model refresh fails, then you can notify someone in your team that this has failed. So this is how we can build dependencies between different activities. Another feature of data pipelines to be aware of is the fact that you can have active and inactive activities. So if you right click on any activity, you'll see this pop-up box. And you'll see that here we have deactivate here, because this is currently an active activity. And essentially what that means is that when you run that pipeline, it's not going to execute that activity. It's just going to go straight to this one will be the first one. And this is what this is going to look like, right? You'll see this kind of grayed out activity box here. And also when you run your activity, it's just going to say inactive. So it's not going to execute this activity. It will just go straight to our silver transform data. Now, this could be useful for a wide variety of things. Sometimes when you're debugging, it's useful to make some of the activities inactive if you're sure that they're working well and you just want to focus on maybe the second half of a pipeline, you can do that. And there's various other ways that we can use this active and unactive. But just know that if you see this kind of grayed out box with this icon here, then that is going to mean that that activity is deactivated, it's not going to run. Okay, so that's some of the basics of data pipelines and how we can construct data pipelines in Fabric. Let's talk about some patterns that you might commonly see in orchestration. So in the basic pipeline example, I was hard coding the relative URL, but the problem with this is that we can only do one data set at a time, right? You can only load one CSV file, for example, into Fabric at a time. Now, normally you want to build your pipelines in a way so that there's no hard coding of things like string values or file paths or things like that, because it means that we can scale them to much larger data set sizes, a number of data sets, without changing the pipeline itself. So one of the main ways that we can do this is build what we call metadata-driven pipelines. This is going to allow us to do things like, oh, I want to ingest 25 different tables from this Azure SQL database, and then I want to load them into 25 separate tables in the data warehouse, right? Because if you have some sort of database in an external system, the chances are that you don't just want one table, you probably want multiple tables in that database to come through. And you don't want to be writing 25 separate copy data activities for this. You want to be building your pipeline in such a way that it can essentially loop through all of those tables just with one copy data activity. So we'll look at how we do that in a second. Another example is I want to query 10 different REST API endpoints to get all of my data out of this SaaS product API and save all of the JSON responses in a Lakehouse files area. Now, a very simple way of viewing what this would look like is essentially you need to store all of the connection details. So what your table name is, what your schema name is in that database. Let's take the first example. You need to store those somewhere in your Fabric environment. Now that can be a data warehouse table, can now be a SQL database table. So now we have Fabric SQL, so we can store our metadata table in there. But it can also be flat files, right? Some people use JSON files to store their metadata as well. And essentially what you're going to do as the first step is to create a lookup activity. Now this could also be a script activity if you've got your metadata in a table format, right? Because the script and lookup can be used for similar tasks in this regard. But essentially we need to read our metadata wherever it lies and bring it in to our data pipeline. And I think of this as like instructions. It's like an instruction manual. So it's going to be 10, or to continue our first example, 25 lines in this metadata table. And these 25 lines are going to say, okay, you need to extract the source table, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 25, into these destination tables, right? Again, and then the destination table is going to be this one here called this. So once we've got our lookup activity here, we can pass all of that information, those instructions, to a for each loop, because we now have 25 instructions that we want to act on. So we want to do for each of them, then you're going to see your copy data activity in here. So for each of my lines in my metadata table, I want you to go away and copy whatever is in the source system and write it into my destination. Now, obviously, we've only got one copy data activity here, so we need to change how we write this, right? So we're going to need this dynamic content, right? So what this is essentially saying is now I'm not hard coding this relative URL. I think before it was addresses.csv. Instead, I'm reading it. So .item, because we're in a for each loop now, it's the current item that you're iterating through, right? So in this example, there'd be 25 items in total, and we're getting the .source property from the current item. Okay, so this is essentially what this means, and it allows us to iterate through all those different metadata items, and we're just passing in dynamically whatever the current value is for source. Now, obviously, the benefit of this is that once our pipeline is set up once, you shouldn't need to edit it, because if you add a few tables into your Azure SQL database and this becomes 27, well, you don't have to change your pipeline at all. Right? All that needs to change is this metadata table. So you've probably got some table and you simply need to add a few new rows at the bottom, which is our instruction manual, as I like to think of it. We're just adding on a couple more instructions, but the pipeline itself is not changing, which is really useful. So in the last slide, we saw an example that looked like this. But what if we had to do lots and lots of things for each of these different items in our for each loop? What if we had to ingest then maybe do some transformation, then we wanted to load it somewhere else into a silver layer, for example, perform some sort of scripting maybe to build our gold layer, and then refresh some semantic model, right? There's a lot to be done there in this for each loop. And so what you might want to think about is doing something a bit like this. Now it's very, very similar, but all we're doing is substituting this logic here, and we're going to bring that into its own pipeline, right? So we'll create a second pipeline. Now this is normally called parent and child architecture. So in this example, this would be the parent, and this, we've wrapped all of that logic and we're building it into a separate pipeline. Now this has a lot of benefits, but it also requires us to construct our pipelines in a slightly different way. So let's look at some of the key features that can enable this kind of architecture. So in our parent pipeline, the most important thing is this invoke pipeline activity, right? We saw that on one of the first slides and we said how useful it is. Well, we need this. Now, currently, I recommend you use a legacy invoke pipeline activity, especially if you want to pass pipeline return values up from the child back into the parent, because that's not currently supported in the preview version of this activity. And this invoke pipeline activity, normally what you'll want to do is configure some parameters in that child pipeline. And then within the parent pipeline, you're going to configure these parameters to pass things into that child pipeline. So in this example, I've got things like source directory, source file name, destination table name, expected column names. So these are things that I need in my child pipeline for it to function, right? For it to be dynamic. And this is coming from the metadata table in this example, right? So we're reading the metadata, and the metadata is going into my for each loop. And then for each individual one, because we're doing .item again, or @item, we're basically dynamically passing in these 4 properties that we're going to use in our child pipeline. So our child pipeline is set up like this. So we're going to have, most importantly, some pipeline parameters in our child pipeline. Otherwise, this wouldn't work. But you need to declare these parameters in your child pipeline first. Then we can use whatever we pass in here with @pipeline.parameters and then the parameter name, okay? You can also get this from the right-hand menu in a data pipeline. You don't necessarily need to remember it off by heart because, there's a parameters tab and you can simply specify, it will show you which parameters are available to you that you can use. So now you would use these in your various for each loops and your if conditions. So when you need to specify your source, for example, I think in here, there is a copy data activity. So now you're not hard coding it, but you're still doing it dynamically, but this time the dynamic parameters are coming from the parent. So it's not just data pipelines, although data pipelines are the primary method for orchestration of Fabric items, we can also orchestrate notebooks within other notebooks. So let's look at notebook orchestration in a little bit more detail. So within a notebook, we can call the execution of other notebooks in Microsoft Fabric. And we're going to do that using the notebook utils package. So essentially, this is a package that's managed and maintained by Microsoft, and it gives us a number of useful functions that we can call. There's things for managing files, there's things for managing your credentials, getting credentials from Azure Key Vault, for example. But the one that we're going to be focusing on is the notebook module, because that allows us to run other notebooks from within a notebook, right? So that's the main distinction between this type of orchestration and data pipeline orchestration. Here, we're only talking about running other notebooks. So if we want to use this style of orchestration within a notebook, we've got a few different options available to us, right? Option 1, if we want our notebooks to be executed in parallel, meaning the order doesn't matter, we're just going to run them all at the same time, then we can use this notebook.runMultiple method, and we can pass in a Python list. And these are going to be names of notebooks within your workspace, right? Again, the ordering doesn't matter because they're all going to be executed at the same time. So the way that we construct this, obviously we need to import the relevant module and library, which is notebook. I've just given it an alias of this module, nb. So nb.runMultiple. Then we're passing in this list of notebook names. So that's the simplest method. But what if we wanted to control the order of execution of these notebooks? Well, as well as a list that we saw, we can also pass into this runMultiple function what's called a DAG, right? So directed acyclic graph. This comes up all the time in orchestration. If you're used to Apache Airflow, for example, runs on things like this. And what you notice is that the DAG is quite similar actually to a data pipeline. If you've ever looked at the edit JSON code view, it's very, very similar. It's just a JSON representation of your activities, right? So you might be thinking, how does this structure encode a graph? Well, there's a few key features that we should dig into here. So obviously we're declaring a variable called DAG. It's a Python dictionary. And one of the main attributes of this dictionary is the activities list, right? So this is going to be a list of objects or dictionaries in Python. And each of these represents a notebook that you want to run, right? So this first block represents one notebook in your DAG. We give it a name and a path to that specific notebook. And there's a few other kind of optional settings that we can also specify here. This one is timeout per cell in seconds, for example here. Then we add another notebook into this list. So my second one is notebook name 2, which has the same path. And the name is the same as the path because they're in the same workspace here. Now here we've got a few extra properties added. We've got a retry property of 1. So if it fails, it's going to retry it again. We've also got a retry interval. Okay, so it's going to wait 10 seconds until it retries. And then most importantly is this dependencies. So this dependencies is how we, as the name suggests, build dependencies between different activities. So it allows us to say, okay, I want you to start with this one. And then when that is completed, do this one. So let's look at what this means. So our second notebook has a dependency of notebook 1, right? So what that means is it's going to start the pipeline. It's going to run notebook 1. And because notebook 2 is dependent on notebook 1, it's only going to run after notebook 1 has finished, like this, right? So that is the dependency that we're basically encoding in this DAG. Now these can get more and more complex. You could have multiple things here and then wait for all of these to complete before you do 2. But essentially it allows us to build up this logic within this structure. Now when you're calling run multiple with a DAG, you can also use this display DAG via graphviz equals true, and it shows you, a very similar diagram to one that I just drew. Now also alongside the run multiple, it's a good idea to use another method that we have called validate DAG. So once you've constructed your DAG, just to make sure that you have actually built it in a correct way, it's always recommended to pass it through this validate DAG method, right, before you do this run multiple. Okay, so that's most of the things that I want to talk about when it comes to notebook orchestration in Fabric. There's just one point I wanted to add on here is that what's the benefit of this? Well, one of the key benefits of this was that you can execute lots of different notebooks, Spark notebooks, from a single notebook, and it's going to use the same Spark session, right? So you can use this to run multiple notebooks within the same Spark session. The problem was that with data pipelines, previously at least, if you wanted to do this sort of notebook orchestration from a data pipeline, it's going to spin up a brand new Spark session. It's going to use a lot of resources for every single notebook, right? Now they have introduced a new feature called session tags in data pipelines that essentially allows you to declare what's called a session tag. That means that multiple notebooks executed from a data pipeline can all run on the same session. So that's less of a benefit now, but that's one of the benefits of using notebook orchestration, or at least it was in the past. Okay, let's round off this session and talk a little bit about triggers in Microsoft Fabric. So the main one is the schedule trigger, right? So if you've got a data pipeline, a notebook, Dataflow Gen 2, all of these can be triggered via a schedule, right? So I want my data pipeline to run every day at 9 a.m., for example, right? You'll need to declare a start time and an end time, and we have this option of declaring the time zone, okay? I think by default it's going to be UTC, but you can change that to whatever makes sense for your organization. Now you can also trigger individual notebook schedules and Dataflow Gen 2 schedules, but I'd recommend doing it from a data pipeline because obviously you can trigger both of these from a data pipeline. And with the data pipeline, you get benefits like error handling, notification and things like that. So in most use cases, I'd recommend creating data pipelines as your primary orchestration tool. You don't really want lots of separate notebooks and data flows triggering on schedules because then it becomes quite difficult to manage, right? You're not sure what gets executed where. It's better to have everything executed through a data pipeline, in my personal opinion. So as well as the schedule trigger, recently they've introduced event-based triggers for data pipelines, and currently this will trigger based on an event in Azure Blob Storage. So if there's a new file uploaded, it will trigger the execution of a data pipeline. Okay, so it looks a bit like this. You're going to have to select which Fabric item you want to run, which is your data pipeline, and you're going to have to select the event. So it's going to ask you for the particular Azure Blob Storage account that you want to monitor for this event, and you're going to have to make that connection, and then it's going to basically subscribe to that particular connection. And when there's any changes, depending on which event you're listening for, it's going to run your Fabric item. Now, this is particularly useful for people migrating from Synapse, for example, and they need this functionality, but they just want to trigger Fabric items rather than ADF. So the other triggers to be aware of in the real-time hub, and this is kind of a developing space in Fabric because this is still preview, as you can possibly see here. But the real-time hub is showing quite a lot of potential in terms of real-time events. So more than just Azure Blob Storage events. In the real-time hub, we have some other event triggers. For example, job events, which are events produced by status changes on Fabric monitoring activities. So a new job created or a new job succeeded, for example. We also have OneLake events. So this is going to trigger on actions in files and folders in OneLake. So that's very useful. And workspace item events, right? So when you create items in a workspace, it will trigger this event. And we can use this again to trigger either alerts. So here we're talking about data activator or activator alerts, I think it's now called, or event streams or data pipelines as well. Now, I just wanted to round off this triggering session with a little bit on semantic models, because semantic models have some new functionality that you can trigger within Microsoft Fabric. So obviously the first one is auto refresh. Within a semantic model, you'll have this option for keeping your direct lake data up to date. Now, if you turn that on, then any changes that you make to your underlying OneLake files, it's automatically going to be visible and updated in your direct lake semantic model, right? Assuming that the user is querying that particular data on the front end. The second one is in the semantic model settings again, we can actually turn this setting off and we can choose to configure a refresh schedule. Or if you're using import mode semantic models, for example, this is like the traditional way of refreshing a semantic model, a scheduled refresh. But in Fabric, we have a few different options. We've seen this one already, the semantic model refresh activity in a data pipeline. So this allows us to integrate semantic model refreshes into our engineering pipelines, right? So you might want to load some different tables into a data warehouse, and only then, when all of your tables have been loaded successfully, refresh your semantic model. One of the negatives of the automatic direct lake refresh option is that it's just going to constantly update automatically all of your tables. So if you're midway through an ETL job, you might have some tables that are fresh data and some tables that have not completed their ETL job yet. So then you risk getting data out of sync to the user on the front end. In option 3, you're gaining a bit more control of that. So you're saying, okay, I only want to refresh my semantic model once I know that these 10 tables have all been successfully updated. And finally, semantic link. So it's not just from the data pipeline that we can programmatically execute the refresh of a semantic model now. We also have a refresh dataset, which is a method in SemPy, so semantic link. So we can now do it via notebooks as well. Thank you very much for watching. I hope you enjoyed that. That's the last of section 1 of the study guide. In the next video, we're going to start looking at ingesting data and data stores and things like that. So hope to see you in the next video.